All right, so questions. Go ahead, Ian.
The first on the third part package, first question.
Number one.
No, it's not number one, but it's the first one on the third package.
Okay, can you, okay. This?
Yes.
Okay. So, total number of different vehicles Josh has to choose from. I mean, you don't have to, everybody, use this tree diagram specifically to answer this question. When you look at the tree diagram, you can see there are three models of vehicles. There's a sedan, compact car, and economy class vehicle. When you look at the tree diagram, you can see that there are three different colors, red, white, and black. And when you look carefully at the diagram, you can see there's two different types of transmissions. So you don't have to use this tree diagram as a counting tool. What you could just do is say that the number of different vehicles is going to be the number of models times the number of colors times the number of transmissions. So we can take 3 times 3 times 2 and get 18. If you want to use, and I'm not going to grab this whole thing, but if you want to use this tree diagram as a counting tool, then you have to remember, and this is interesting because this tree diagram is done sideways and every one we did was top to bottom. If you want to use this tree diagram as a counting tool, then you need to appreciate that each of these is a choice. Are you with me on that? So that's 1. I'm going to run out of colors. That's 2. Sure, that's 3. We also have another one here. That's 4. We've got another one here. That's 5, and then 6. But I mean, that gets very cumbersome, tedious, long-winded. It's much easier to just dissect the problem and read how many of each choice you have and multiply them together. Okay. Other questions? Leslie? 99. Okay. So we want to solve this equation, and this is a very good question to know how to solve algebraically. If I saw this as a written response worth 3 marks or something, I wouldn't be surprised on an exam. Diploma exam or unit exam or anything. Probably 3 marks. It wouldn't be 2 marks. This is an exponential equation, everybody. The unknown is part of the exponent, so you have 2 options. You can either write everything with the same base, or you can use logarithms to solve for x. You can't write everything with the same base because 3 and 5 are not compatible in terms of bases. So we're going to have to take the logarithm of both sides. So I'm going to write log of 3 raised to the 2x minus 6 has to be equal to log of 1/5 raised to the x minus 1. And the purpose of doing that, of course, is that you can move those exponents out in front. And now we have 2x minus 6 multiplied by log of 3 equals x minus 1 multiplied by log of 0.2. I'm just getting a little tired of writing 1 over 5, so I've decided to write 0.2. Okay. There's only one move you can make here to proceed, and that's to multiply this all out. You have to multiply this log 3 by the 6 and by the 2x, and you have to multiply this log of 1/5 by the negative 1 and by the x. You have to do that to get those terms with x out in the open, right? The x's are buried inside of something right now. So when I do that, I get 2x log 3 minus 6 log 3 equals x log 1/5 minus 1 log 1/5. And now what we can do here is move all of the terms that have x to one side. So I'm going to take the 2x log 3 and leave it alone. I'm going to subtract the x log 0.2. And then I'm going to add the 6 log 3 to the other side. Still with me? Okay. Finally, well, not quite finally, but we're so close to being done. You factor the x out of the left side, and you get 2 log 3 minus log 0.2 equals 6 log 3 minus log 0.2. So we can divide both sides by that 2 log 3 minus log 0.2. And that would be our answer. You know, I want to point out to everybody that, sorry, I just had to sort something in my head, that since this is a numerical response question, there would be nothing wrong with you exploring a solution graphically by graphing y1 equals the left side and y2 equals the right side and finding the point of intersection. But what if it's a written response, right? Other questions? Marcel, I saw your hand up. 151? So you're asked to determine an extraneous root. You know, every now and then I like to point out to you the probability of seeing something like this on a diploma exam. I think it's a little thin. I don't think you're likely to see this, but I have seen it. Remember, an extraneous root is a value that you get when you solve the equation algebraically properly, but the number doesn't work. So the very first step in solving a radical equation is to isolate the radical, so I can write 2x plus 6 as a radical equals x minus 1. I square both sides. That, of course, eliminates the radical on the left side, and then I get x squared minus 2x plus 1 here, because, of course, this means x minus 1 multiplied by x minus 1. It's a quadratic equation, which means you have to zero it. I subtract 2x from both sides and get x squared minus 4x. I subtract 6 and get minus 5. We're going to factor this into x minus 5, x plus 1. So that means that x is equal to 5 and x is equal to negative 1. So these are the two solutions. A and C are not even solutions. They're not solutions and they're not extraneous. One of these numbers will work when we put it back into the original equation and one will not. And I will tell you right now that if you put negative 1 in, you're going to get 2 times negative 1 plus 6 under the radical plus 1 equals negative 1. That's not going to work, because it's equal to negative 1. All right, this is going to be a positive number. Plus 1 is another positive number. Can't get a negative out of that. So that's why the correct answer is B. Other questions? Go ahead, Leslie. 108? So this is an application of exponential growth. More specifically, this is an application of this formula from your formula sheet. Okay. In this formula, A is the initial amount of whatever is growing or decaying or declining. It's the initial amount of the stuff. So if Jimmy puts $1,500 in an account, that's the initial amount in the account. P and B are a little bit trickier. B is the number that the initial amount gets multiplied by regularly. So if I were to just tell you that something is growing by 5% annually, you would say that B is 1.05. Except this isn't 5% annually. It's 5% annually, but it's compounded monthly. And what that means, I will draw this with a... I will represent that year. This is 1 year. And just say to you that you get 5% in the whole year. But they're going to give you some of it every month. So you're actually only going to get this percent each time. And this gets very tricky. It really does. Because this is a percent, right? Let's do this on the calculator. 5 divided by 12 this is a percent. And you look at that and you think it's a decimal percent, but it's not. It's a percent. If it were 2%, we would write 1.02. So in other words, we have to take, and we've done this before, I'm going to clean this up a little bit. It's 5/12ths of a percent. B is going to be equal to 1 plus the percentage over 100. We have to divide that percentage by 100 and add it to 1 because we're adding it to 100%. And that means that when I divide this by 100 and then add 1, this is B. And again, it's deceptive because when you see that 0.416 repeating, you might think that's already in a decimal. But I hope you understand that 0.416 repeating is like 42%, and that's not what it is. So anyway, B is 1.04, 1.0416 repeating. And P is the period of time it takes to happen. Well, that's 1/12th of a year. So we're dealing with a lot of decimals here. .0.083 repeating. So this is the setup for the problem. Now, what is the actual question? The question is, when does it exceed $2,000? Now, we do have an option here. You know what we could do is we could... This is years, right? You could put 1 in for P and then just use your time in months. That would work as well. And I'm inclined to do that. So what my formula is is y is equal to, and this is a beast of a question. It is not a simple question. It's that. Where t is in months. If I put that 0.08333, that other number, then t would be in years. But since we're asked about months, I think this is the most direct thing to do. Because this is such a complicated question up to this point, I'm not going to solve it algebraically. I'm going to solve it graphically. We want this, well, I'm not even going to solve it graphically. We want it to be equal to 2,000, don't we? So I'm going to put this expression into my calculator for y. And I'm going to go to my table. Because compound interest is a discrete thing, which means your balance stays at a fixed value and then all of a sudden it jumps, and it stays at a fixed value and it jumps. It doesn't go up continually. I can set up my table to start at 0 and go up by 1. Now I suspect that I might be doing a lot of scrolling here. So I can use a little bit of common sense here and say, well, maybe I shouldn't start at, say, 6 and go up by 1. Maybe I'll start at 20 and go up by 1. I don't know. You can poke around in here. It's going to be more. Let's go for 40, 50. We can always scroll backwards. Well, we're getting very close. So we have to be careful on how the question is worded. I think the question says, how many complete months until you pass $2,000? So the answer will be 70. Okay. If you were going to solve this algebraically, then you would divide both sides by 1,500 and take the log of both sides. And by the way, if it is a monthly or even a quarterly thing, I would recommend doing the time in months. Because if you did it in years, all you would discover is that it passes $2,000 at the end of a particular year, but you wouldn't be able to figure out very easily after how many months. It would require a lot more detailed analysis. Okay. Other questions? Go ahead, Marcel. 158? 159. This is really at its heart a transformations question. This, I know it's taught to you in rational functions, but it's really about transformations. You need to start off knowing what y equals 1 over x squared looks like, though. Okay. So y equals 1 over x squared looks like that, with a horizontal asymptote on the x-axis and a vertical asymptote on the y-axis. I'm just going to move the vertical asymptote over so you can see it. So if I vertically stretch that, and we need to look at the question here. The question is asking about the asymptotes. I would never, I'm guilty of this sometimes. I think I did it in the last question. You should read the whole question first. Find out what it is you're after. Okay, so we're after the asymptotes. Will a vertical stretch of this graph by a factor of 3 change the location of any asymptote? Well, no, because stretches are always away from axes. So this means we're going to stretch it 3 times further away from the x-axis, but the x-axis is where the asymptote is, so it's not going to move. If I reflect this vertically, the asymptote will stay in the same place. If I translate this 4 units to the left, then the asymptote will be at x equals -4. The vertical asymptote will be at x equals -4. And if I shift it 5 units up, the horizontal asymptote will be at y equals 5. So the answer is A. Okay. Other questions? 41? Certainly. So we want to know the x-intercepts of this new graph. And we're given the graph of the function, and the new graph is g of x, which is -3 of 1/2 x. Now, what does the -3, yeah?
Sorry, 41.
Did I not grab 41? Oh, geez, I'm sorry. Sorry about that. There we go. Okay, sorry about that. So the red graphs, interesting. So let's take a look at the first part of the question. You're given g of x and f of x, and then you're given n of x and m of x, and you're told that g of x is equal to, it's at the bottom of your screen, af of bx. What that means is f of x is stretched and or reflected to get g of x. A is the amount of the vertical stretch. So when you compare the height of f of x to the height of g of x, has the height changed? So what is the value of A? It has to be 1. Okay? So A is 1. G of x is going to be equal to 1 f of something. When you take a look at the width of g of x, is it the same as the width of f of x? No. So how has f of x been stretched? By 1/3. It's only 1/3 as narrow. So if it's a horizontal stretch by a factor of 1/3, what is the value of b? Right. So this is 1f of 3x. And then we're going to do the same thing for going from from m to n. So from m to n involves no horizontal stretch, which means that n of x has a b value for m of 1. You know, what makes this confusing is all the different letters, isn't it? Has m of x been stretched vertically to get n of x? By what factor? 4. So that means that A is 1, B is 3, C is 4, D is 1. Is that okay? Ian?
258.
Okay. Is that in trig?
Yeah, no, that's it.
Okay. Oh, why does it? Well, this is kind of the same as the one you had asked about earlier, except you don't have any details about what A, B, and C are. Student models a problem with the following diagram. The reason why the answer has to be an arrangement and not a selection, by the way, just to make sure everybody's on the same page, arrangement means permutation, selection means combination. Okay? The reason why it has to be an arrangement is all of these have A, B, and C in them. Right? If this was selecting three people, well, ABC and ACB and BAC, etc., are all the same. What we have are three different items, A, B, and C. And this is showing that they can be arranged in the order ABC, ACB, BAC, BCA, etc. So the answer to this question is three people being arranged in a row. It's not six people, it's six arrangements that we're looking at here. Does that help? Okay. Leslie. 63? So we are after the domain of the inverse of this. One very, very useful thing with regards to inverses of relations is that when you do an inverse, you're swapping out x and y. What this means is if you wanted to plot the inverse, you could start taking points like this point here, which is at -3, 5, and you could flip those numbers and plot 5, -3. But that's not what you want to do to answer the question. If you switch x and y, then the properties of x on the original become the properties of y on the inverse, and vice versa. In other words, the domain of the inverse has the same properties of the range of the original. The range of this you can see is y is greater than or equal to -3. That's the range of the original, which means the domain of the inverse will be x is greater than or equal to -3. And this is why I was very careful in saying what I wrote. It's not the same. It's the same properties because the range of one is y, the domain of the other is x. So it's x is greater than or equal to -3, and that means it's -3 to infinity. Other questions? Go ahead. A little louder, please. 65? So this is still related to this graph. So is the inverse a function? Well, you should not have to sketch the inverse to decide it's not the function. With a parabola's inverse will be a parabola laying on its side, and that will fail the vertical line test. I mean, if you want to take a look at what this thing will actually look like, it will look approximately like this if you were to start swapping all of the x, y's, or if you were to reflect it in the line y equals x, it would look like that. But it's not an inverse. You can also decide that it's not an inverse because if the inverse, or it's not a function, if the inverse is not a function, it fails the vertical line test. That means if the original graph fails a horizontal line test, then the inverse will not be a function. Okay? So that's not true. What else do we got going on here? The inverse has an x-intercept of -1. Well, again, I'm doing this whole x, y swapping properties thing. look at the graph on paper. Is the y-intercept of the original -1? It is. So if the y-intercept of the original is -1, then the x-intercept of the inverse is -1, because x and y swap. So number 2 is correct. Will the inverse have 2 y-intercepts? Well, only if the original has 2 x-intercepts. So does the original have 2 x-intercepts? Yes. So the inverse will have 2 y-intercepts. I'm going to capture this now because it's starting to get a little more convoluted. The inverse passes through the point 5, -3. Well, that will be true if the original passes through -3, 5. And again, the purpose in doing it this way is avoiding the nightmare that would be plotting all of these points to find the inverse. The original function, does it pass through -3, 5? It does. Which means the inverse will pass through 5, -3. Does the inverse pass through 3, 1? Well, only if the original passes through 1, 3. And the original does not pass through 1, 3, which means the inverse will not pass through 3, 1. So the answer is 2, 3, 4. Other questions? Yeah. 60? So what is the inverse of this function? When you find an inverse, what you have to do is switch x and y and then rearrange for y in equation form. So I'm going to take this equation, which is y equals x minus 8 quantity squared. I'm going to switch x and y and get this. Now, that's the inverse. Unfortunately, life is not that simple. One of these things is equivalent to this. So we have to rearrange this for y. I'm going to have to take the square root of both sides first before I can get rid of that 8, because the squared is on the outside of the operations. So that means I'm going to have plus or minus root x equals y minus 8. And then you can see that the answer will be 8 plus or minus root x when you add 8 to both sides.
So could you also do 61?
Absolutely. Take a look at 61. This is one of the greasiest, slipperiest things to wrap your head around for students. There's a restriction, and maybe it's because of the way it's always worded. There's a restriction that we could place on the domain of this original function so that the inverse will also be a function. So first of all, not worrying about where it is. This is a parabola that opens up. Yes? Which means the inverse will be a parabola that opens sideways, because they're reflected in the line y equals x. Okay, so it's kind of folded over at an angle. Is this inverse a function? No. Why not, in your own words? Right, the vertical line test shows that it's cut at least twice in many places. And the way I prefer to think of it is, the reason it's not a function is there's a top and there's a bottom. So if there were no top, it would be a function. If there were no bottom, it would be a function. Now, why is there a top to this? There's a top to it because there's a right-hand side. The right-hand side becomes the top. And there's a bottom because there's a left-hand side. The left-hand side becomes the bottom. So I think you get it now, but I'm going to finish the explanation anyway. The bottom line is if we could restrict the domain of this original one by saying only look at the left side or only look at the right side, then we would answer the question. And that means we need to know the x-coordinate of this point. So if we know the x-coordinate of the vertex, we can just say, well, x is greater than that number, and that will give us only the right side. Or x is less than that number, and that will give us the left side. So then we're back into transformations. Y equals x squared is a parabola with its vertex at the origin. Y equals x squared minus 9 will have its vertex down here at 0, negative 9. So if x is greater than or equal to 0, it will be a function when we reflect it. You're welcome. Marcel? 176? So we've got part of a circle, and you're going to travel from A to C. It says in order to travel from A to C, you can follow the curved path, or you can travel from A to B and then to C. Okay. You can either take the path I'm going to highlight in yellow, or you can take the path I'm going to highlight in green. And you can see very clearly that the path in green is 120 meters. Okay. The question is asking you to compare that path to the path along the curve. And one of the things we learned in this trigonometry unit is that an arc length, this is an arc length, is related to the radius of the circle and the angle by the following formula. The angle equals the arc length over the radius. And we know the angle, it's 130 degrees. And we know the radius, it's 60 meters, so we can calculate the arc length. Okay. The only catch with this is in this formula, this must be in radians. So what you're going to have to do is convert 160 degrees to radians. Now, if I had to guess, I would say that this process of converting degrees to radians would never be asked on a written response. I really doubt it. So there's lots of ways that we can do it, but if it was asked on a written response, you would do it this way. You would say pi rads is 180 degrees. That's x rads over, I can see that I wrote 160. I meant to write 130 degrees. So that's how you're going to calculate what x is. We'll have 130 pi over 180. And it is a multiple choice question, so we can, and the answer is in decimal form, so we can feel free to say, you know what, I'm not going to simplify that. I'm just going to take 130 pi, 130 pi divided by 180. This is how many radians that is, 2.2 something. So now I'm going to put that into my formula. This is the angle in radians, so I'm going to have 2.2689 equals the arc length over the radius, which is 60. and I can multiply those two numbers together to get the length of the curved path. And you get 136.1 something. So this is 120 meters. This is 136.1 meters. You can see that, eh? Not really. It's pretty gross. I thought I would try it. This is 136.1 meters. The question is, the distance along the dotted lines is, so is the distance along the dotted lines longer or shorter? Shorter. By 16.1 meters. Good? Okay. Leslie? 112? Well, I hate this question. I really despise it. And in the past, I remember one year me going, let's just not worry about it. And it was on the diploma exam. So it's a very bizarre question. It seems like there's too many variables. We have this equation that says the loudness of sound, that's L. The loudness of the sound is equal to 10 times log of I over I0. Now, I is the intensity of the sound. So really what you can do here is think of this as being like an X and this as being like a Y. The L0 is just a parameter. It's some number. It says it's the intensity of the sound at a threshold level. And that's the thing that screws this up. Okay? So the loudness of a siren is 40 decibels. Then the intensity of the siren is how many times greater than the intensity of the threshold level. Well, if we put 40 in for the loudness, we get 10 log I over I0. This I over I0 is what we're asked to find. It's how many times greater the intensity is compared to the threshold level. So imagine that I over I0, forget about this question, was 20. Just if it were 20, that would mean the intensity of the sound is 20 times greater than that threshold intensity. So once you wrap your head around that, and also once you remind yourself that this is a base 10 logarithm, it's just a matter of rearranging for what's in brackets. I need to divide both sides by this 10 to get 4 equals log base 10 of what we're after. And then remember, big lifesaver here, if you're unsure about the meaning of a statement that involves logarithms, write it in exponents instead or vice versa. So when I write this logarithmic equation in exponential form, I get 10 raised to the 4 equals I over I0, which means that it's 10 to the 4 times as intense as the threshold level. Yeah. 84? So remember, everybody, that X-intercepts are where y is equal to 0. So for the first layer of this question, number 84, if we have y equals log base b of x, and we put 0 in for y, and we rearrange that, we get b to the 0 is equal to x, and b to the 0 is 1. Okay, so the y-intercept, the x-intercept of this graph is 1. If we do the same for the second one, I'm going to have 0 equals log base b of x minus 2. I'm putting 0 for y because the second part of this is saying what's an x-intercept. I write it in exponential form. B to the 0 is 1, so I get 1 equals x minus 2, and I can add 2 to both sides to get 3. With the third one, there's no algebraic way to do the third one. You need to start off knowing that y equals log base b of x is a logarithmic function with a vertical asymptote, that's a little overdone, but with a vertical asymptote on the y-axis. And you need to understand from Unit 1 that when we change x to x minus 1, we're introducing an h value of 3, which shifts us 3 to the right, and that means, 1 to the right, and that means it will be at 1. Yep. Oh, I see, yeah. 1 plus 2 is 3. This is a 3. Is that good? Okay. Arden?
Can you do question 5?
Certainly. So you understand that this is still related to these graphs? Okay. So we are asked for the number of x-intercepts on the product. Now, this is a good question because you can't deconstruct these graphs into equations and use your graphing calculator. You need to understand what's going on. When we talk about products of functions, or sums of functions, or differences of functions, or quotients of functions, we need to remember that it's y coordinates that are being manipulated. So when I say I want to take f of x and multiply by g of x, what's happening is that individual points on the two graphs come together in some kind of union which will look like this. Now, this is just a bizarre notation. It's just something I'm using as a teaching tool. I'm telling you that it's the y coordinates that get multiplied. So what is an x-intercept? An x-intercept is where y is equal to 0. And the only way that this can equal 0 is if the y coordinate on f is equal to 0 or the y coordinate on g is equal to 0. And there was a good question on your unit exam dealing with this that I'll put up in a second. So there's this place right here on f where y is equal to 0. So that means that the multiplication of these two functions will produce an x-intercept at that point. There is also a point here that has a y coordinate of 0. What I'm really telling you is that when you have functions being multiplied, every x-intercept stays an x-intercept. And then we're also going to get one here and one here. You want to be careful, so I'm counting 4. You want to be careful here because if this is at 3, and this were at 3 as well, You wouldn't count that twice. So the answer is 4. For number 5, that's it. The question that was on the exam that sometimes gives people a difficult time, I don't remember it exactly, but I will make one up to drive my point home. Had maybe a cubic function. And it also had a linear function. And how many x-intercepts would the product of that have? And the answer is 4. And some people forget to consider that this continues and it's going to intersect somewhere. Anyway, is that okay, Arden? Okay. Other questions? Marcel? 182. 182. Is that in trig? Thank you. I don't know if this advice is valuable or not, but when you see a standalone question like this, like there's not a bunch of information elsewhere, and it's just a standalone question, and there's not even really a lot of information in the question, there's got to be a simple way to answer it. Like, finding the simple way is the difficult task. One of the most important aspects about the unit circle, not even related to the big unit circle we construct in class with root 2/2 and all that stuff. One of the most important things related to the unit circle is the following. It's on the unit circle, x squared plus y squared equals 1. And I'm going to put 1 squared because if the radius were 2, it would be equal to 4. And you just immediately went, oh, you get it, right? The bottom line here is negative 0.8 squared plus k squared equals 1. So k squared will equal 1 minus negative 0.8 squared. Man, I hope that if you were making the mistake of not including the negative in the squaring at the beginning of the semester, that you've learned to put it in brackets. I wouldn't even put the negative in there. I would just go 1 minus 0.8 squared. It's not really that simple because then you have to take the square root, right? So when you figure out what 1 minus 0.8 squared is, I believe you get 0.36. No? And you take the square root of that and you get 0.6. There's a reason why you're being told it's in quadrant 2, and it's because if you're not, then you would say plus or minus root 0.36. You'd get 2 solutions, one for quadrant 2 and one for quadrant 4, I guess. No, 3. Is that okay? All right. Other questions? Go ahead, Ian.
How come this 182, how come the answer says it is 0.6?
Because the square root of 0.36 is 0.6. We're not done, right? You have to take the square root. Yeah.
Could you also do 183?
Okay. Give me a second, please, to look at it. And I know where you're coming from, but the difference between 182 and 183 is a matter of how the question is asked, okay? So let me explain this. It's the same question, really. In fact, what we did, it's exactly the same, right? We go 1 minus the negative 0.8 squared, you get 0.36. So k equals plus or minus square root of 0.36. You do the exact same thing here, except it's not 0.8, it's 0.2. So we would write 0.2 squared plus k squared equals 1. So you get k squared equals 1 minus 0.2 squared. You get k squared equals 0.96. Which means k equals plus or minus 0.96. Now, that's 183. Question 183. In question 182, we had k is equal to plus or minus, well, are you okay with me just saying plus root 0.36? Because it was in a particular quadrant. What's the difference between these questions? Because in 182, the answer is 0.6, isn't it? In 183, the answer is 0.96, right? It's because in question 182, read it carefully. It says, what is the value of k? K is the square root of 0.36. In 183, it does not say what is the value of k. It says that k is equal to plus or minus the square root of some number. I don't know what letter they used. And they're not asking you for k, they're asking you for the number that you will take the square root of to get k. And we're taking the square root of 0.96. Other questions, Leslie? 57? A very important point, and I hope to get my videos done for the review tonight. And I really think it's valuable that you find some time between now and Friday to watch them. A very important point about reflections and invariant points is that a point that's on a line of reflection will be invariant. Forget about vertical, horizontal, everything else. If I reflect something across a line, that means if the point is on one side of the line, it will go to the other side. And if it starts on the other side, it will go to the one. But if it's on the line, it will not move. So, how is that in any way helpful? Well, you do need to understand that this is a vertical reflection across the x-axis. So for the first one, we are reflecting across this line, and there's one point on that line. Everything else is below, so when we reflect it, it will go above. That one point will stay on the line. You need to know that for the second one, this is a horizontal reflection across the y-axis. And that is a reflection across this line. So all of this will go to the other side. All of this will go to the other side. But this singular point here is going to stay in the same place. So there's one invariant point there. Now, when it comes to x equals f of y, this is an inverse, which is a reflection across y equals x. Is the answer to this question 1, 1, 1? Oh, I actually want to put the point. Which point? I gotcha. So the point is 0.5. I didn't read the question. Does that make sense? And the point is 0.3. y equals x is a line where y equals x, which is here, and that's 0.1. Okay. This question could have very easily as well said how many points, in which case it would be 1, 1, 1. Is that okay? All right. Other questions? Ian?
Will we be asked to find the inverse of a square root function?
Potentially, yes.
How do we do that algebraically?
You swap x and y or rearrange for y. So if I gave you the following original function, O for original, y equals 1/2, let's go full blown here, everything, and I say, what is the inverse? The inverse will be x equals 1/2 x minus 3 squared plus, y minus 3 squared plus 7. That's the inverse.
I mean, but that's the inverse of a quadratic. I mean, the inverse of a square root function.
Oh, I'm sorry, I misunderstood. But I want to finish this anyway. You would rearrange this. I would subtract 7 from both sides. And it's actually maybe a good thing that I'm doing this because your question is the same as this, it turns out. And I'll show you why. Then I would multiply both sides by 2. You could multiply everything by 2 to begin with. My mistake here. Subtract 7, you get x minus 7. Multiply both sides by 2. This is equal to y minus 3 quantity squared. Then you would go plus or minus the square root of this. And then add the 3. So the reason why I'm saying your question is kind of the same as this is it's true that this thing I'm pointing at is the inverse of the first thing, but it's also true that the first thing is the inverse of the second thing. So the procedure is the same. It's just that instead of taking a square root, we're going to be squaring. Allow me to demonstrate. If you had y equals 1/2 root x plus 1 minus 3. That's an original function, right? The inverse, now there's a little wrinkle to this that I don't know that we need to worry about, and I may talk about it. The inverse will be this. And now what we would do is rearrange for y. I would add 3 to both sides. I would multiply both sides by 2. I would take the square of both sides. And then I would subtract 1.
Is the wrinkle, well, I guess my question was more or less, if you have plus or minus root sign, that is not one function, that is two functions.
Right. That's the wrinkle, right? And, you know, I can explain it to you. I don't want everybody to worry too much about this because I don't think you might be asked about this. See, this original function has that for a domain, doesn't it? Because x plus 1 must be greater than or equal to 0. And what that means is that this has to have this for a range, which means that part of this function might not be valid. And that's the wrinkle. I don't think you would see it. It's pretty messy. I mean, think of it this way too. This thing that we're claiming is the inverse down here in the bottom right is a parabola, isn't it? This is only half of a parabola. So you would actually have to put a domain restriction on here.
And we don't know how to do that.
You're not expected to know how to do that. Correct. Yeah. You bet. 199. Are we still in trig, Marcel? Okay. A fairly classic question. I would say that, as likelihoods go, this is very likely that you would be asked something related to this on an exam. This is all revolving around the fact that x over r is cosine of theta. Y over r is sine of theta. And tangent of theta is y over x. We also need to know in all of this that x squared plus y squared equals r squared. So since we know that the terminal arm passes through 3, -6, we can calculate r. You would say that 3 squared plus -6 squared is r squared, and you would get r equals root, 9 plus 36 is 45. So cosine, is the first one supposed to be cosine? I've cut it off. Sine. Sine is y over r, so it's going to be -6 over root 45. But unfortunately, that's not there. However, -6 over root 45 is the same as -6 over root 9 root 5. So what we're doing here is we're simplifying the radical for root 45. 9 is a perfect square that goes into 45. This gives me -6 over 3 root 5, and -6 over 3 is -2. You can proceed and finish the question now. Just let you know that we are going to have to shut down a few minutes early because I have supervision again on the other side of the school. So we're still good for another question or two. Other questions? Yeah.
You said that it would be if there was a range restriction on a square root function, the inverse would have a domain. Sorry, a domain restriction on a square root function. The inverse would have a range restriction.
Correct.
How come they both don't have domain restrictions?
Well, they both will. They both will. Because a square root function, just picture any square root function. You know what it looks like, right? It will be let's just say x is greater than or equal to some number and y is greater than or equal to some number. The inverse will have to have those same properties switched for x and y. So, for example, if this is your square root function and this point is at 2, 3, then x is greater than or equal to 2, y is greater than or equal to 3. And you know what? Maybe we shouldn't call them domain restrictions, because I don't want you to confuse what we were talking about before, which is turning it into a function. Okay? The fact of the matter is, there are restrictions on this because of the domain and range. Okay. If I were to graph the inverse, now I'm not graphing it on the grid, I'm just saying that it would look something like that. right?
That's on the bottom?
Say again?
That's on the bottom? Like that's the bottom of the function? Or
There is no top and bottom. The inverse of this will look like this. If I reflect this in the line y equals x, I get something that looks like that.
shouldn't it be like this and not like this?
No, it'll be like that. Shouldn't it be like what?
This instead of
Well, I'm okay. You want to. You get the idea, though, right? This point here is going to become 3 comma 2, isn't it? And that means x is greater than or equal to 3. And y is, why am I getting less than? Boy, that's messy.
well,
That doesn't make sense to me.
if the square root function
Oh, I see what you're saying. Yeah, no, I get it. Like this, that's what you're saying. Okay, you're right, and I'm wrong. And you would have y is greater than or equal to 2. I was way off base on the direction it was moving. But the bottom line is, since there was a domain and a range of this, it becomes the range and the domain of this. But again, I wouldn't worry about that. Okay. Are you writing a Physics 30 exam today? A rewrite? Were you wanting to do the math rewrite? Sorry?
I'm not sure.
Okay. Because I don't think you've even seen your exam yet, eh? I can give it to you now, and I have to leave just in a few minutes, but you can look at it here and then just leave it on your desk and close the door when you leave. Okay? All right. Sorry for being rushed around. When the bell rings,